Okay, let's talk about, let's continue on with our topic of product and quotient rule. We went ahead and I went ahead and typed these in for you. So this will be on Saul's version of the notes, not on the original notes, but it will definitely be on Saul's version. So the derivative of tangent of x is secant squared x. The derivative of cotangent is negative cosecant squared x. The derivative of secant x is secant x tangent x. And the derivative of cosecant x is negative cosecant cotangent x. And yes, you need to learn those. You need to have those memorized. You need to know them throughout the rest of this course, along with the fact that derivative of sine is cosine x, and the derivative of cosine is negative sine x. You need to know those. All right. I also had to make an adjustment to this problem. I realized I had typed it in wrong, so I went ahead and fixed it before we carried on. So, all right. Now, here's what we're going to do. I'm going to go ahead and go through, and I'm going to write down we're going to focus on the first part here. I'll do that on this slide, and on the next slide, I'll derive that, and you'll see how they're both the same. Okay, so it ends up being, when I derive it, y prime equals, it ends up being, I'm just going to write it down, sine of x times sine of x, because that's the derivative of negative cosine of x. The derivative of negative cosine x has got to be sine x, minus, and it's going to be 1 minus cosine x, and then times cosine of x, all over sine of x squared, equals, and when I simplify that, it's going to be sine x squared, or sine squared x, minus. Now, I distribute that, I get minus cosine x, and then minus minus makes it plus cosine squared x. Now, here's the thing, and this is all over sine squared x. Now, if I group these two together, I'm going to highlight those two. If I group these two together, if you recall from pre-calculus, sine squared x plus cosine squared x is 1. So it's going to be 1 minus cosine x all over sine squared x. So y prime equals 1 minus cosine x all over sine squared x. All right. So that there equals 1. Now, if I go about it from this way, if I rewrote this as cosecant x minus cotangent x, because cosine over sine is cotangent. So if I do it this way, so I got y prime. Y prime equals the derivative of cosecant is negative cosecant x cotangent of x. And then that's going to be minus cotangent with derivative of cotangent, which is negative cosecant. And I wrote it wrong, so. All right. Now, here's one thing I know about that. Okay, minus negative x plus positive. And that's going to be cosecant squared x minus cosecant x cotangent of x, which if you end up doing the algebra, you will figure out and you will see that it is just exactly like 1 minus cosine of x all over sine squared x. Those two are equal. So however you go about doing it, it'll work just fine. All right, now, and also, and most of you are doing pretty good about this, but make sure if you have any questions, make sure you email me and get in touch with me so that way you can get them answered. All right, higher order derivatives. Note that velocity is the derivative of the position function, or position function is s of t. To find the acceleration, we take the derivative of the velocity. In other words, to obtain acceleration from the position function, we would take the derivative twice, or the second derivative. And note the progression as you see below. Velocity equals s prime of t, which is the velocity function, where s of t is the position function. And the acceleration is the derivative of the velocity. And you see the second derivative of s of t is the acceleration function. Those are all things you need to be aware of. Oh, I like pink. My daughter likes pink, so I like pink. All right. Lovely colors. Lovely colors. All right. Now, and I'm going to fill this in right here. The second derivative of st was written as s double prime of t. This is an example of a higher order derivative. The third derivative would be the second derivative would be the third derivative would be the derivative of the second derivative and so on. All right, and there's a second derivative, third derivative, fourth derivative, and the nth derivative. So, and those are all the way it's written. You'll be seeing those throughout this class, so be prepared for that. All right. Now, let's do one last one right here. Okay. The position function. The position function of an object falling on the moon is given by the equation s of t equals negative 0.81 t to the second plus 2, where s of t is the height in meters and t is the time in seconds. Okay, a little bit of physics for you if you've taken physics class. If you haven't, a little preparation for you if you end up taking it down the road. Okay, so here's what we know. We need to know two things. First of all, we know that s prime of t is negative 1.62, because I take two times that t, which is equal to the velocity function. Okay, so velocity function is right there. And then s double prime of t, which equals v prime of t, which equals the acceleration in terms of t, is just simply negative 1.62. All right. Now, what is the ratio of the Earth's gravitational force to that of the moon's? Okay, so the ratio here is this. The ratio is going to be from the Earth to the moon. Remember, the Earth's gravitational is negative 9.8 meters per second. And the gravitation on or the acceleration or gravitation on the moon is negative 1.62 meters per second squared. So, when you do all that, you simplify, you're going to get approximately 6 times, or 6.0 times. That is why, ladies and gentlemen, there is the gravity here on the moon, or here on Earth, is 6 times that of the moon, and why the gravity on the moon is 1/6 that of here on Earth. So, that's that. That's section 2-3. Product and quotient rules. Go ahead and start working on WebAssign for this Friday, and I'll have other information for you in the coming days. So go ahead and get to work.